Good morning, grade 11s. So today we're going to do the theorem, which I will call theorem 1.2, which says that if the perpendicular bisector of a chord, if the perpendicular bisector of a chord is drawn, then the line will pass through the center of the circle. And then the short reason that you will write when you apply the theorem, you will say this. So when you apply the theorem, this will be the reason that you'll write, right? You will say perpendicular bisector through center. Perpendicular bisector through center. And then now we have the circle, and then I'm going to draw a chord. So we have chord AB, and then I'm going to draw the perpendicular bisector. So this is the perpendicular bisector, which I will call QP. So this is the perpendicular bisector, and then because it's a bisector, it means it divides the chord into two equal parts, right? And then this is what we start with. So it means we are given a circle, right? And then with midpoint P, a circle with midpoint P So we are given a circle with midpoint P on chord AB. So we want to prove this theorem, and the other part that we are given is that, and also we have that it's a perpendicular bisector, right? So it's a perpendicular bisector, so it means we are given also that what we have is that we also know that QP is perpendicular to, so this is what we are also given, and then AP is equals to BP. So this is what we are given, and we have to use what we are given to do what? To prove that the line QP passes through the center of the circle. So it means we are required to prove that QP passes through the center of the circle. This is going to be an interesting proof, very interesting. So the first thing that we are going to do is to do a construction, right? So we'll say construct. So let me show that this is the proof now. So the proof, so we are going to start by construct construct POR, where O is the center. So I'm gonna construct POR where O is the center. So this is my POR that I'm constructing. So then I have, this will be R, and then the center, I'll put it here. This will be center O, right? And then now we can start. So then we're going to say that angle APQ, sorry. So angle APQ is equals to angle BPQ. And both of them, they are what? They are 90, because of it's given that QP is perpendicular to AB. So it's given, we are given that BPQ is 90, so they are perpendicular, so we know they are both 90, right? And then we're gonna say AP, next we're gonna say AP is equals to BP, and then this one is also given, right? And then after that, because AP is equals to BP, it's a chord, right? And then we see that OP is a line from center. Can you see that? OP is a line from center, right? So then it means we can claim that OP is perpendicular to AB. And the reason why OP is perpendicular to AB is because of what? The converse of theorem 1. So the converse of theorem 1. The reason here is the converse theorem 1. And the short reason that, or the other short reason you can write is that line from center to midpoint is perpendicular to chord. Line from center to midpoint is perpendicular to chord. And then now because we have shown that OP is perpendicular to AB, right? Then I can claim now that therefore we can say that APO, angle APO is equals to angle BPO, and they are both 90 degrees, right? And the reason why they are both 90 degrees is because of we just shown that OP is perpendicular to AB, right? And then now the next step, we are gonna now use this. So we're going to use this fact here, right? And this fact here in the next step. So because of APQ and BPQ, they are equal to 90, and APO is equals to BPO, they are also equals to 90, right? So then I now claim that APQ, it follows that APQ must equals to what? APO. And they are what? They are also both 90. So they are both 90, right? And then I also claim that BPQ is equals to BPO. And another is because of they are both 90, so they must be equal because both of them are equal to 90 degrees, right? So do you see that APQ is equals to APO and BPQ is equals to BPO? They are both 90. So it means that now we can make a conclusion, right? So then it follows that, therefore it follows that QP and OP lie on the same line PR. So QP and OP lie on the same line PR, right? And line PR passes through the center of the circle. Therefore, QP will pass through the circle center. So then we have proved, this is what we wanted to prove. So then we have proved that QP will definitely pass through the circle center. That's what we wanted to prove. We were required to prove that QP passes through the center of the circle, and then we just proved that. This is an interesting proof. So bye for now. See you next time.